Hello, welcome for part 2 of the mini-serie Publish Your Own Golang library. So previously we did a design pattern, the composite pattern last week, so then we could recursively display a tree structure thanks to that pattern. So today we will work on the existing code base so then we can print in a very nice way our tree structure. So if you enjoyed the video, like, and don't forget to subscribe if you want to have the update of the next episode next week. Alright, happy video. Alright, quick recap of what we did last week. So we just used the composite pattern to display like a tree structure, data structure. So you can see there I've got a branch which has multiple leaves and can have multiple branches, and a branch can have itself leaves or other branch. So you can see the pattern in action. We just use recursion, and the pattern allows you to work with node tree with interface. So I can do recursively tree.display, whether it's a leaf or a branch, and then I'm ensure that they have components. So you can see that last week we simply printed them with two double spaces. So I just changed double underscore, but what we want to achieve there is just like this kind of ASCII tree. I found a library which might be more challenging. So this is that library. It's written in Go. So we are not using the same pattern or same code base, but the tree has some nice prefixes. So it looks like that. So you have some nice pipes in front of the each node. So we will try to replicate the same. So it's fun, and it allows you to understand recursion and stuff. So visit that GitHub, the GitHub of Tuffin. Sorry if I didn't say it right. And all right, let's go. So we are in a range statement, and I was just prepending the existing prefix with double space. So we will probably have to hold the previous prefix. So if we create to start with very step-by-step a struct called prefix, and then we have the content, which is the content of the prefix, called string. If we create a method function on that prefix, just call display, that we will be able to invoke. Same strategy as tree.display. We want to have the prefix.display. We don't want to put too much code in our recursion loop, because usually they are quite complicated to manipulate. So let's start little by little. So you can see those fancy pipes, three-way pipe, or just a 90 degrees pipe. So they are different whether the node is last or not. So we can start with that. So you can see that I did the field is last. So if the prefix, actually it's not really a prefix there, it's a bit a poor choice of naming. It's just we're just manipulating the node really. So we will rename that into node, so n.node. So if our node is last, we will just, the prefix will be, well, the prefix, the content of the prefix, and then we want the adequate pipe just before the name. So if it's last, we want this. So it's a bit cryptic, but it's just the UTC character for the three-way pipe. Otherwise, you just want the 90 degrees bended one. So here I've got a notepad that you can't see, but that's a UTC character for that. Okay. So can we try just to see what it does? So we have the prefix there, so it's not a prefix. We want now a node dot display. like the tree and display. So we're not passing around a prefix now. We are passing a node which can carry persistence layer. Persistence layer is a big word, but it's just that it's carrying the prefix string, so you can manipulate it and grow it as you go through the recursion loop. Don't worry for the recursion loop now, so let's initialize our do print with a node. So for the first element, there's no previous prefix, and it's the last item. Yeah? And then within the loop, we need to figure out if the child is the last one, and we will have to grow the prefix. So previously we were just doing plus double space, so now we have to do something more complicated. Okay, so as usual, let's do baby steps. So let's call it attached to the node a function called iterate, and we can nicely do all our operations within a function and not polluting the recursion loop. So you can see that quickly change the signature of that iterate function. So it needs to be, it doesn't need to be, but I could mutate the current node. That would be a bit nasty. So I just use like a little bit of functional programming style by just creating a new node from that iterate method. Okay, so alright, so we need to figure out if the child will be the last child. So it's fairly easy. So we just need to calculate we just need to get the length of the tree.components, and then because we're in a range loop, we have access to the index, so it will be last if the index is the length -1. Pretty straightforward for Go. So then we can send that to our iterate function. So is last is the child last. So it's a wrong method here. It's not the display, but the iterate function. Okay, so then here we can populate is last with child is last. So here it's a bit not very happy with that variable name. We can simply call it is last because it doesn't need to understand what's a child here with a node. Okay, so so next step, as I said a few minutes ago, is to calculate last, but also to parse and iterate the prefix, the content prefix. So so it will be the prefix, the current prefix, plus an iteration. So we can keep what we had before, the double space, and we can try that out. So there you can see, really nice. So you can see which node is last and which node is not. So then you can see the little pipe accordingly, which is really good. But unfortunately, it's missing like the straight pipe in the middle if your current branch wasn't the last one. So for instance, sibling 1 is different than sibling 2, for instance, which has a pipe. So for instance, sibling 1, if we just break it down a little bit better, so sibling 1, so root 1 is the parent, but root 1 wasn't the last child because root 2 is the last child. So but for sibling 1 line 51, root 2 is the parent, and root 2 is indeed the last one. So this is how we're gonna manage to calculate accurately our prefix, by adding a straight pipe or not. Okay, so go back to our recursion loop. So we need to understand if the parent was last or not. But the good thing is parent or child doesn't matter because now we have a node. So, and we are calculating is it last. So we will be more specific with our function iterate. It's just creating the child node basically. So node inside the doPrint function is a parent, and we will create a new node line 18 for each component in that components method. Okay, so let's just create a function. So a little bit of functional programming today. So we can create a function, a method on the node that we can call it the next prefix. So it will return you the prefix. So it can simply, if the node was last, we will return, so that's sibling 1 line 57, so double space, otherwise we will print a straight pap. So yeah, so I've got the notepad, so the UTF character for a straight pap is just 2502. Here I'm just copy paste what it will look like in case there's a bug. So you can see I'm adding some comments at the end of lines 30 and 32. And then finally we can invoke our on line 37, our function next prefix. So you have the prefix, the node prefix, and the node.next prefix. You can see it's all good and it's quite comprehensive code. So 3 function broken down, and you have a beautiful ASCII tree. So all good. I did it multiple times, but recursion is a little bit difficult, so I didn't want to pollute that do print function. Otherwise it's really complicated to debug or to understand or to extend. So I went, I prefer to break down things even though they are really tiny. So you have a function to display, a function to iterate, and so on and so on. And then if you need to debug or need to extend something, the little something will be tiny and easy to understand as a little unit, atomic unit. All right. Okay, so part 2 is done. So we have now a beautiful ASCII tree, printable. So I hope you enjoyed the video, like and subscribe. Stay tuned, the mini series is not over, and see you next week. Bye. Happy coding.